let us discuss a very important theorem. So in this theorem, we have a matrix space XD and two things we are going to prove. The first thing is arbitrary intersection of closed sets is closed, and the second thing is finite union of closed sets is closed. So we are going to prove two things here. First of all, we will try to prove the first part and then we will discuss the second part. So in first part A, what we have to prove? Arbitrary intersection of closed sets is closed. So let us take a family of closed sets. Let script C will denote it by f alpha. Alpha belongs to lambda. Be a family of closed sets in X. So this is a family of closed sets, and what we have to prove? To prove that their intersection f alpha belongs to lambda is closed in X. What we have to prove? Arbitrary intersection of closed sets is closed in X. So we have to prove their intersection is closed in X. Okay. See what we have. We have, I will write here, we have f alpha is a closed set, right? For all alpha belongs to lambda. Let me write it properly. It's a closed set for all alpha belongs to lambda. So you know that when we say a set is closed, the set is closed if its complement is open. So here f alpha is closed, that means 101% f alpha complement is open in X for all alpha belongs to lambda. So in case of open sets, we have proved one result. Arbitrary union of open set is open. So that's why if you take their union 101%, it is an open set. So I can write here. So implies union of f alpha complement alpha belongs to lambda is open in X. So the reason is since arbitrary union of open sets is open. Arbitrary union of open sets is open. Okay, but you remember De Morgan's law? So that De Morgan's law says, union of f alpha complement alpha belongs to lambda. This is nothing but intersection f alpha belongs to lambda whole complement. Okay, whole complement. That means if you take that complement common, then union will be replaced by intersection and intersection will be replaced by union. We have already written this is an open in X, so that's why this set, both of them are same, na? So we can write this is also open in X. So implies intersection f alpha belongs to lambda complement is open in X. See, its complement is open, that means the set is closed. So therefore intersection f alpha belongs to lambda is closed in X. So in this way we proved that arbitrary intersection of closed sets is closed in X. So first part is proved. You can make a screenshot of it. After that we will go for second part. Okay. Let us prove the second part. In second part, what we have to prove? Finite union of closed sets is closed. So we have a finite number of sets. So let us take let f1, f2 and so on fn be closed sets in X. Only finite number of sets I have taken, okay, up to n. So set is closed. Okay, so just a minute. I will write what we have to prove. To prove that, what we have to prove? Finite union. So union fi, I running from 1 to n is closed in X. So see, we have to prove that their union is closed. We will start with the given thing. So that's why we have, I will mention clearly, I will write the same sentence again. Now we have f1, f2 and so on fn are closed sets in X. So you know that if set is closed, that means its complement is open. So tell me, what can I write then? So therefore, what can we write? F1 complement, F2 complement, and so on. Fn complements are open sets in X. Since given sets are closed, so that's why their complement is open. So in case of open sets, we have a very nice result that finite intersection of open sets is open. So that's why we have a finite collection. So that's why therefore we can write intersection Fi complement I running from 1 to n is open in X. Open in X. So actually the reason is finite intersection finite intersection of open sets is open in X. Finite intersection of open sets is open in X. So therefore, but De Morgan's law says intersection Fi complement, okay, Fi complement I running from 1 to n. This is nothing but union I running from 1 to n Fi whole complement. That means if you take that complement common, then union will be replaced by intersection and the intersection will be replaced by union. So this is a De Morgan's law. So see, both of them are same. So therefore this is open. That means this set is also open. So therefore what can we write? Union I running from 1 to n Fi whole complement is open in X. Open in X. So you know that if complement is open, that means the set is closed. So implies I can simply write union Fi I running from 1 to n is closed in X. Right? So finally we proved that finite union of closed sets is closed in X. So in this way we have completed their proofs. You can make a screenshot of it. After that we will stop. Thank you. Bye bye.